Hi, in this video we are going to discuss for the paper 1, the trial paper 2024 for the MRSM. So let's begin. Okay, so this is a diagram that's showing the atomic model, and then from the diagram we can see that this is a nucleus that contains the proton and electron. So the question is asking which of the following scientists discovered this model. So we have A, B, C, and D. So for A, John Dalton stated that the matter is made of atoms. So, but this question is related something to the proton and electron. So A will not be the answer. Meanwhile, for the Ernest Rutherford, he found that proton is in the nucleus of the atom. But even though it mentioned about proton, but these scientists did not find the electron. Meanwhile, for C is a Niels Bohr, so he suggests that electrons move around the nucleus in a fixed path called the electron shell. So obviously this is the answer because it mentioning about the electron and together with the proton because around the nucleus. So James Chadwick found the neutrons in the nucleus. So this is actually from the Form 4 Chapter 2 syllabus. So this is considered quite easy for this question. So you guys need to memorize like what are the important achievements or discoveries found by the scientists. Okay, next. Question 2 is what is the chemical formula of tin 4 oxide? So for your information, when we want to write a chemical formula for a particular chemical compound, sure, we can look at this. So this question is tin 4 oxide. So we know that the chemical symbol for tin is Sn. And then this 4 means that this is the oxidation number for the tin. So when we want to write the chemical formula, this is 4. So we need to write 4 on top of the Sn. And then all is 2. The reason why the oxidation number here for oxygen, for the oxide, is 2 is because it needs 2 electrons to achieve octet electron arrangement. So when we want to write the chemical formula, let's cross it. So we also copy down the tin over here, but we copy the oxide oxidation number, which is 2, over here. And then also we copy down the all, then we cross the oxidation number for the tin to 4. So 2 and 4, they are multiples of each other, so meaning that we can simplify it. So when we simplify it, the answer would be D, Sn or 2. Okay, diagram 3, question 3 shows the is asking what is the special characteristic for transition elements. So okay, let's look at the answer one by one, the option one by one. So first is high density. Okay, transition elements is also sometimes contain matter, so it is high density, but it is not special because matter like the group 1 elements, which is sodium, potassium, they are also high density. So B is can conduct electricity, but we also note that metal can also conduct electricity. C is solid with shining surface, also the same. Transition elements and metal, they all also share the common characteristic for A, B, and C. Last but not least, for the option D, it shows that the transition elements have more than one oxidation number. So for your information, tin is a type of transition element because it can exist in tin 2 oxide, tin 2, or tin 4, just like here. So usually when the naming has this kind of numbering, it is highly possible that this element is actually a transition metal because only transition elements can have more than one oxidation number. So this option will be the answer. For information, like copper, the one that we will usually see, is also a type of transition element where it can exist in copper 2 ion form or copper ion. Okay, let's continue with question 4. Diagram 2 shows a standard representation for potassium 39. So this is the abbreviation that I write. So electrons is I write like this, and then from this diagram we can get two information, which is this is for potassium 39. This 39 is actually referring to the nuclear number. So as what I mentioned before, nuclear number is equals to the total number of protons plus neutrons. Meanwhile, over here the number downwards is the number of protons, and we know that the number of protons is equal to the number of electrons. This is the hidden message before after it. But the question is asking which of the following is correct for potassium ion. So when it is an ion, metal ion tends to donate electrons. So when it tends to donate electrons, and this is a plus, only one plus, meaning that it only gives out one electron. So when we want to find the number of electrons, it would be 19 minus 1, because it donates one electron to form the potassium ion. So the number of neutrons we can get easily from the number of the nuclear number minus the proton number. So from the question we know that the nuclear number is 39. Then we minus 19, which is the proton number, and we will get 20. Yeah. So for the number of protons, it doesn't involve any changes because it's not involving in donating or accepting things. It is fixed in the nucleus. So the answer would be A, which is the number of protons is equals to 19, the number of neutrons equals to 20, and the number of electrons is minus 1, 18. So if the question is asking like what is the correct, which of the following is correct for K, then the answer would be B, because one is metal, or we say element, another is ion. So for ion, they are not the same. Okay, let's continue with question 5. Table 1 shows the position of element L and M in the periodic table of elements. So also this is quite similar to the question 2. The question is asking what is the chemical formula of the compound formed between element L and M. So actually we can ignore the period informations because it is not needed or used in solving this question for me. So only if I was needed to answer this question, so I will directly look at the group, because group gives off the information related to the valence electron. So for information, this group 13, okay, meaning that it has 3 valence electrons. Meanwhile, for element M, it has 6 valence electrons. The reason why is because we can write out the electron arrangement for the element itself. So it match these 13 and 16. So it means that in the valence electron shell, it has 3 and 6 valence electron in it. So obviously, we can assume that this is a ionic compound. So let's say we write out just like the procedure we do for question 2. We can write the element L, and then 3 plus is because it has 3 valence electrons. And then we write out M with 2 minus. The reason why we put it as 2 is because it's still lacking 2 electrons to achieve stable octet electron arrangement. So when we cross it together, we copy down the L, and then copy down the opposite charge, which is 2, and copy down the M. Lastly, copy down the opposite charge from L, which is 3. So the answer would be C, L2, M3. So if you know that, we can actually, when you don't know, and then you can referring to the periodic table. So L is actually aluminium, and then M is ore. So one is metal, another one is non-metal, showing that this is actually a ionic compound. Okay, Question 6. What is the unit for the molar volume of gas? So we know that molar volume is equal to volume divided by number of mole. But, okay, the volume is in the unit of dm cube. Meanwhile, for number of mole, the unit will be mole. So when we do a simple math calculation, we move this mole to the upper side, it will become dm cube per mole. So this is the answer. So actually, you no need to memorize the unit for the molar volume. As long as you remember the formula and you know a little bit of simple mathematical calculations, you can derive the unit by yourself. Okay. Question 7. Element X is located in the same group as calcium in the periodic table of elements. So calcium is actually found in group 1. It is group 1 metals. So same group meaning that these element X share the similar chemical properties with calcium. So we know that for group 1 elements, they can react with water to produce an alkaline solution and hydrogen gas. And it also can react with the chlorine gas to produce a white solid. Okay, let's continue with question 8. So this table shows the electron arrangement of 4 atoms. So based on the information in table 2, which pair of elements that form a compound that consists of neutral particles? So the keyword is neutral particles. So when the compound consists of neutral particles, we can highly assume that it is actually a covalent compound, because covalent compound has no charge, which is neutral. So opposite to the covalent compound is the ionic compound. Ionic compound contain charge. So when it contains charge, when it contains charge, it can sure conduct the electricity. So do you know how to form the covalent compound? Covalent compound is formed from the sharing of electrons between one nonmetal with another nonmetal. Meanwhile, for ionic compound, it is formed from the transfer of electrons from the metal atom to the non-metal atom. Okay, so also the same, given that the electron arrangement, and then usually always the last digit will be the valence electron. So we can copy down 1 valence electron is actually metal, 4 valence electron is non-metal, 3 valence electron is metal, and then 7 valence electron is non-metal. So once you write out this valence electron, you will know that actually for the valence electron from 1 to 3 usually will be the metal, and then 7, the same thing, 4 to 7 will be non-metal. So we already know that in order to form a covalent compound, we need it to be non-metal. So sure, the answer will be X and Z, which is C. Okay, question 9. Which of the following salt does not dissolve in water but dissolve when heated to produce a colorless solution? So for your information, A and B is insoluble salt, so it will not dissolve in water. So the answer will be C, which is lead 2 iodide. Lead 2 nitrate will dissolve in water. This is soluble. Okay, A and B is insoluble. So this requires the students to memorize a bit for the classifications of salts based on their solubility. Okay, question 10. Diagram 3 shows the bond X between the water molecules. So this is actually quite direct question, because we know that water molecules is very special, as the bond inside that connects each water molecules with another is actually the hydrogen bond.